Functions. My first veto? Or no? My first rearrangement already? A function is a rule that pairs an input with an output. Okay. Now what the rule actually ends up being is kind of like the problem. Kind of like, you know, you're multiplying by 2. You're going to add 6. You're going to divide by 7. Whatever the case may be, the function is the rule that has both of these inputs and output. So basically, you'll take an input, which you'll plug into your problem. Once you plug it in and do the work, it'll spit out the output. So you put something in, you'll get something out. If you put something different in, you'll get something different coming out. Okay? It's really not that bad. It really is. A lot of people think these are not that. You've done more challenging things, put it this way. Okay? Let's see. For example, let's give us a fresh page and say, we'll make ourselves a little table. We'll call our input X. Your output is Y. Okay? Give yourself a minute to set this up. The table itself. Your input is usually going to be represented by the letter X, or if they use other letters, it's going to be, you know, usually the first one that's in alphabetical order. So if you had an input of A, your output's going to be B. If you had an input of M, your output will be N. Alphabetical order. Now the rule is Y equals X plus 7. So that's our rule. And every function table will have a different rule. This function table happens to have y is equal to x plus 7. So here, in this column, are all my what values? X. So all my x values. So what I do is I'm going to take this value for x, I'm going to plug it in. 3 plus 7 gives me an output of 10. So I'm going to plug in a 5 next. That's going to equal my y, which is 12. 7 plus 7. And then finally 9 plus 7, 16. So we have just completed the function table. Okay. So you'll plug in, and they'll usually give you, and they have to give you one. Sometimes they'll give you the input. Sometimes they'll give you an output. Sometimes they'll give you a mixture of each. and say, okay, you got to figure out the missing values, which really isn't that bad, because if they give you the output, you can find the input. It's just like solving an equation. You would just do the opposite, okay? So instead of adding 7, you'd have to subtract 7 to find the input, which wouldn't be that hard at all. For example, let's add one on here. Let's say they gave you an output of 20, but they didn't give you the input. How could you set it up? X is what we don't know, plus 7, they say, is equal to 20. So it just looks like just one of these equations that we worked on earlier in the week, or was it last week? I can't keep track of days anymore. How we find our value by doing the opposite, which is what? We'd subtract 7 from both sides, and X would equal 13, and I can plug a 13 right in there. Okay, so once you have your table established, you can find either input or output once you have the rule. Once the rule is in place, okay, everything else just comes after. Okay. All right, let's try one. If you want, and you try it all by yourself. Input. Let's not do that. Let's not do that. Let's keep it simple. We'll use X and Y for now. Okay. And 0, 1, 2, 3. Now the rule, Y equals 50X. Let's plug it in. If input X is 0, what's 50 times 0? If input is 1, what's 50 times 1?
50.
If input is 2, what's the output? And if it's 3, 50. I mean, you got it correct. Awesome. Okay. Very good. Input, let's call A this time. We'll call B. Two-thirds A, 0, 3, 6, 9. Now, when we see something like this, you say, uh-oh, a fraction. Well, what is it that you remember about multiplying with fractions? Everything has to be in fraction form. So 2/3 times A is equal to 0 over 1. What does that equal? Anytime you multiply anything times 0. 0. Let's set this up. 2/3 times 3. 3 as a fraction? Anything in common? Equals 2 over 1, which equals 2/3 times 6, which is 6 over 1, equals, there's 2 there, there's 1 there, equals 4. And 9 equals 6. Done. Yes.
These function things is always a sort of pattern.
Yep. Exactly. There should be. Why? Because they're all following the same rule, right? Well, Carlos, that's funny you should say that. Because what they will do sometimes is they will give you the table and have you come up with the rule. Give it a shot. As I go from X to Y, what's happening to the overall value, Zay? We're getting bigger, larger, right? So then as I look at 1 to 4, I'm either multiplying by, or 1 to negative 1 to 4, I'm either multiplying by -4, or I'm adding how many? So let's test that adding 5, because I know if I multiply 0 by anything, that's going to be 0. Is that 0? So I must be adding 5. Is that true for 1 plus 5 is 6, 2 plus 5 is 7? Good. So now I'm going to write the rule as what, Zay? There it is. That's your rule. Y equals X plus 5. Carlos. You subtract it. I would say what would probably be your best move is to work with your input to see what you're getting for your output. Okay? Work input to output. Now, let's see which side. You're welcome. You're welcome. De nada. Okay, let's take a look at on 13.3. Make sure you're looking at 13.3. Do numbers 6, 7, 8, and 9 in class. On 13-3. Number 6, y is equal to x plus 4. Eli, come on up and finish out that table. Number 6, finish it out. Number 7, Larissa. B is equal to A divided by 2. Very good. How many of you had 6 and 7? Entirely correct. 6 and 7. Both of those. Good. Number 7, we need a rule. Taz. Taz says that n is equal to m plus 4. Raise your hand if you are in agreement with Taz. You should be. Looks good to me. Number 8. Let's see. Edsel. So it says y is equal to x minus 3. How many of you are in agreement there? Awesome. Maybe get all 4 of these correct. Well, I guess that means we're ready for an assignment. Turn it over. 13-4. Numbers 1, 2, 3, and 4. They give you the input, and they want the output. So for number 1, you're multiplying your input times what? 7. So you're going to have, for 6, if you plugged in 6 for n, 7 times 6 is
14.
good. And then 2, and then 3. What about number 4? Number 4 says this is your output. N over 3 minus 2. What are you going to do to n? First thing you're going to do is what? No. First thing you're going to do is what? What does this mean? Dividing. You're going to divide it by 3. Let's take a look at the first one. It's negative 6, right? Then we're going to subtract it from 2. What is negative 6 divided by a positive 3? Negative 2. Negative 2 minus 2. Negative 2 minus 2 is negative 2 minus 2. Negative 4. What happens if you plug a 0 in there? 0 divided by 3 is what, Casimir? You tuned me out already. As soon as you saw that fraction, you were like, forget it. 0 divided by 3 is what? 0 divided by 3. 0, then 0 minus 2. 0 minus 2. What kind of 2? Negative 2. 5 and 6 ask you a couple of questions. If the function rule is 8x plus 5, what's the output when x is negative 3? If a function rule is negative 4 times x over 2, what's the output? Don't worry about number 6. Cross out number 6. But numbers 7, 8, 9, and 10, you should be able to tell me what's happening. Give me an output. What's the rule? They put the rule by the output on that side. It's the same thing.